Okay. All right. So this is the first problem from the problem set. It's dog names. So the problem says Victor has decided to get a third dog to accompany Benito and Chico. However, he wants to be more quirky this time, so he's decided he will only choose a name from a list of names if it is a palindrome. So we want to help him figure out if it's a worthy name. So before we can you mute yourself? Someone is back. Okay. So before we discuss what a palindrome is, we're just gonna read in the input so we have like the setup for the problem done. So the first thing we want to do is create a scanner, and let's just call it in. That reads from system. And our first input is going to consist of integer t, which is the number of entries. So we just use the in.nextInt method of scanner to read that. And then we know that we're going to have t inputs after that. So we can create a for loop, which goes like counts up to t. But before we create our for loop, we have to remember that right now, after doing in.nextInt, our cursor is going to be like right after the 5 and not at the new line. So if we try to read like the next line, it's just going to read like an empty line. So we have to do a dummy in.nextLine before we do anything else. But then we declare a for loop, which is going to go from I equals 0 to I equals t and increase by 1 each time, because that'll count up from 0 to t and will run exactly t times. And once we have that, we're going to read the name from our scanner using in.nextLine. Okay, so we have this set up, and now basically all we have to do is look at this name, figure out if it's a palindrome or not, and then print a statement. So before we can move on, we have to discuss what a palindrome is. So a palindrome is a string which reads the same forward and backwards. So for example, Bob is a palindrome because if we reverse Bob, then it would still be Bob. But Danny is not a palindrome because Danny reversed is Yayanginadad, which is not Danny. So the way we're going to be figuring out palindromes is we basically can compare like different like pairs of characters within the string to figure it out. So let's take, for example, the word Hannah. Hannah is a palindrome. And the way we like figure out if a string can be a palindrome is we basically can split it down the middle, and we can compare the first to the last, the second to the second to last, and the third to the third to last, and like so on and so forth if the thing is longer. And the reason this works is because when we reverse Hannah, the first character is going to be sent to the end, the second character is going to be sent here, and the third character is going to be sent here. So now the way we actually code a solution to check if these are similar is we need to check like all the pairings, and we know the total number of pairs we have is just going to be equal to the string length divided by 2, because we only need to like check the first. So the first thing we do is create a for loop which goes from 0 to length over 2. And let's just say like it counts using j. And then the way we compare indexes is before I go over that, we're going to need to use a method called string dot, like it's a char, the method char at. And char at is a method which you give it an integer, which represents an index, and it returns a character of the string. So if we have a string called Hannah, and we do the string dot char at 0, it would return the character h. If we do char at 1, it would return a. If we do char at 2, it would return n. So we basically can do this over here. We can compare the char at j. We compare the char at j to its corresponding character. And the way we figure out like the corresponding character over to the other side is by like deriving an expression. And so to do that, we first look and we see that the last element is going to have an index that is equal to the length minus 1. Because Hannah has a length of 6, and 5 is the last index, and it's always just going to be the length of the string minus 1. Now, so the 0th index compares to the index that is 0 to the left of the last. The first index of Hannah compares to the character that is the first index to the left of the last one, and then the second index of Hannah compares to the index that is 2 to the left of h. So the way we can figure out how many like to the left we have to go from the last is just by subtracting the current j we are at. So then it's just a matter of comparing the char at j to the char at length minus j minus 1. So now we go back over to our coding solution. Now, so the way we want to implement this is we're first first, we just have to make sure, like, if we find any of the pairs that we discussed before that is false, then we know that it's not a palindrome. And we know if they're all true, then it is a palindrome. So for now, we're going to declare a Boolean, which is going to represent whether or not the palindrome, like the string is a palindrome. And we're just going to default and presume that it's true. And the reason we're presuming that it's true is because we're just going to go through, and if we find one of the pairings before that are not equal to each other, we can set it to false. And if we find like that they're all equal to each other, we just won't do anything and it'll just already be true. So for Boolean is palindrome equals true, we're going to do, Boolean is palindrome equals true. And then we're going to do a for loop, which is going to count from 0 all the way to name dot length divided by 2, because we only need to like compare like half of it since each pairings are like 2 different numbers. So we declare a counter. We have to use j this time since we're already using I in this for loop. So for j equals 0, j is less than name dot length. And the dot length is a string method which returns the number of characters within a string divided by 2. And we increment j by 1 each time. And as we discussed before, the two that we're comparing is name.char at j and name.char at name.length -1 minus j. So we have this, and the way we're going to check is we don't really care if they're equal. We only care if they're not equal. And in the case when they're not equal, which we represent by doing this, then we would set our isPalindrome variable to false. So if they're not equal, we set isPalindrome equal to false. So now we know for each of our strings whether or not they're palindromes, and the only thing left is to like print the output that the problem asks for. So if it is a palindrome, the problem tells us that Victor would approve. So we would print system.out.Victor approves. And if it's not a palindrome, which we can just represent with an else, we can just print Victor disapproves. And then that's sufficient for the problem, and we'd have our output, so we're done. Then just check to make sure we don't have any syntax errors. And we do, because we mistyped our thing, but that's no big deal. And we got it correct, so we submit our code. All right, so that's that problem. Yeah. So next, we have the digging holes problem. So Benito has decided to dig 5 holes in Victor's backyard. After he has dug these holes, he decides he wants to see how deep 2 of the holes he's dug could be if they were stacked together. He decides to find the added depths of 5 pairs of holes. Help Benito determine how these pairs are. And then our input will first start with 5 doubles, corresponding to lengths of holes. And then the next 5 lines will contain 2 integers between 0 and 4, corresponding to indices of the holes that Benito wants to add together. So, and then we output like the length of the holes added together. So basically what we do is, like always, we start by declaring our scanner. And then what we're going to want to do is we know there's 5 inputs. So we're going to create an array of size 5 known as, which we can call like hole sizes. So double array hole sizes equals new double. And we know that there are going to be 5 holes, so 5. And then we're going to use a for loop to read in each of our inputs, because if we could do it by hand and just do like hole size 0, hole size 1, but that would take very long. So we do a for loop that goes from I equals 0 to I is less than 5 and I plus plus. And this will go through all the different indexes of hole sizes, because hole sizes has an index 0, 1, 2, 3, 4. And then we just set hole sizes of I equal to in.next. And the problem says that we're having doubles, and we can just do in.next double, which is a method of scanner, which works similar to integer, but just reads doubles. So now we have all of our hole size array declared. Now we want to like finish the problem, and it says that we're going to have 5 more. The next 5 lines will each contain 2 integers between 0 and 4, corresponding to the indices of holes Benito wants to add together. So then we're going to read in, we're going to do another for loop. It's going to have to go 5 times. And the first integer, we're just going to call hole index 1. So int hole 1 equals in.next line int whole2 equals dot next line. And now we just have to add these two together. So the problem is asking us to add together the size of the two holes that are corresponding to these indexes. And since we stored it in an array, we know that the current array we have, if we access the first index of the array, it will return this. The second will return this. The third will return this. The fourth will return this. Well, sorry, the 0th will return this. The first will return this. The second will return this. The third will return this. And the fourth will return this. So basically, we can just use the numbers we read directly and access it as the index number for our element, because this 0 corresponds to this and this 2 would correspond to this. So we can have a sum variable, and it has to be a double since this is a whole size is a double array. And then we add whole sizes of index whole1 and whole sizes of index whole2. And then we just print out. And this is all that the problem asks us to do. So now we just run our code to check for it. And oh, yeah, we used the wrong method here. It should not be in.nextLine. It should be in.nextInt. Yeah, so we got it right. Now, this odd thing has happened here, which I'm not entirely sure why that's happened, but it still counted it right, so we should be good. But alternatively here, if we can do all of this in actually one line by just reading the inputs. We can directly print, and then we can do the sum that we talked about before. If we just take whole sizes of in.nextInt plus whole sizes of in.nextInt. And then this line we have right here is logically equivalent to these 4 lines, just like combined into one. Because the first thing this will do is it'll do in.nextInt, and then this will return the whole size of that index, which is what we're doing with this statement and this statement. And then this will do the same thing, but with the nextInt and this statement. And then it'll do the print statement as before. So if we just comment out what we have here, this will also work as our. Yeah, and then we submit. And we got it. Okay, so now moving on to number 3, bones collections. This problem is very similar to the last problem. It asks us, Chico has 5 bones of numerous lengths. Chico needs help with doing 2 things. First, help Chico organize his bones by creating an array of integers with lengths. Second, have Chico have 3 friends come over who each want a bone and give them, they give an index of it. So the first line contains 5 integers, which are the lengths of our bones. And then we have 3 lines denoting their indexes between 0 and 4. So yeah, so same setup as the problem before. First, we're going to establish our scanner. And similar to the last problem, we have 5 inputs, but this time they're integers and not doubles. So in the last code, we did a double array, but this time we're just going to do an integer array. So we do int array bone lengths equals new int array. And the problem has told us that we have a total of 5 different bones. So we set the size of this equal to 5 here. And similar to before, we're going to create a for loop to read in all of these. And then we set bone lengths I equal to in.nextInt. And then this will just create an array with the first 5, and it's integer instead of double. It's the same concept as the last problem. And then we just are going to create a for loop to read in our next 3 inputs, because the problem says we have a next 3 lines. So just goes from 0, 1, and 2. And then for each of these, we're going to read in the number, which is going to represent the index of the bone that we're returning. So int bone index equals in.nextInt. And then we are going to print out the length of the bone at that index. And we already have it. We know that this number will be between 0 and 4. And the array structure we've set up will already do it. So we can just directly put the index of this number and access the array element at it and then just print it out. So system.out.println. bone lengths of bone index. Then we run our code, and we got it right. And then same thing as before, we can just get rid of this and directly just do in.nextInt here. And that saves us an extra line. And then we submit. All right, so we got it right. Now let's go to the fourth problem. Again, this problem is somewhat similar. So Chico and Benito have 3 stacks of bones. However, over time, the 2 dogs will add and take away bones, help them keep track of the number of bones they have. And our input is that the first line will contain 3 integers corresponding to how many bones are in each stacks. The next 5 lines will contain 2 integers. The first integer will be the stack's index, and the second integer will be -3, will be an integer between -3 and 3, corresponding to how many bones will be removed or added. There's no constraints. And then we're going to be outputting a single integer, 3 integers on a line corresponding to the sizes of our 3 stacks of bones. So the first thing we're going to do is, like always, declare a scanner. And then we know that we're going to have 3 bones, so we're going to create an array of size. We know that we're going to have 3 bone stacks, so we're going to create an array of size 3 to hold the lengths of these 3 bone stacks. And then we're going to create a for loop instead of just like directly like assigning them, because we don't want to have to rewrite the same statement 3 times. So we can just do a simple for loop that goes 0, 1, 2. And then we can set bone stacks of equal to in.nextInt. So now we have just an array that's storing 25 at index 0, 73 at index 1, and 14 at index 2. Now we have to go through and do all these operations to change the number of bones in each stack. So if we go back and look at the problem, we know that we're going to have 5 more lines that are each going to contain new integers. So we're going to do a for loop, which will go through 5 times. So we just go I equals 0 to I is less than 5 and increase by 1 each time, and then it'll count 5 times of 0, 1, 2, 3, 4. And we're going to set up 2 variables. The first variable represents the stack index, as it says, and the second integer represents the bone change. So we can just assign the names into variables. And then now we want to like change the value of like the specific bone stack at like the index of stack index by the amount of bone change. And the way that we're going to be doing that is, first we're going to find out like which stack we're talking about, and we can do that by just doing bone stacks of index stack index, because as the problem shows, like it says it's like already the stack index, and we already have it stored such that this would be index 0, this is 1, this is 2. So we start by doing that. And what we're going to do is we're going to use an operator called plus equals. And what plus equals, this sign right here, does is that basically it's going to assign this variable. It's going to add like whatever we put on this side. So if we do like bone stack stack index plus equals 5, this is equivalent of saying bone stacks of stack index equals bone stacks of stack index plus 5. And that's all this operation right here means. And it's just like a quicker way of doing it. And so we do bone stacks plus equals bone change, because the problem establishes that this integer right here is the number of bones we're changing by. And we know if it's positive, it's just going to add that many to the stack. And of course, if it's negative, it'll add a negative number, which is technically subtraction. And then, right, so this will just edit all of our bone stacks through the 5 times. And then we have to finish the problem by doing the output of the 3 different integers that they want. So then we're just going to do system.out.println bone stacks of 0 plus bone stacks of 1 plus bone stacks of 2. These are all just like the different. And we're plussing these spaces in between because the problem asks us to add spaces in between each integer. And then make sure we add the colon, and then we check to see if our code has any syntax errors, and it doesn't, and we pass. Before I submit, there's just like a few different optimizations that we talk about to make it quicker. So first, as we've done before with this, we can condense this and just directly do in.nextInt for the indexes we're accessing and the bone change, because this statement right here is logically equivalent to these 3 lines, since stack index is just in.nextInt, and then bone change will just be in.nextInt. So yeah, there's that. And then additionally, if we wanted to do this, we could also just do a for loop, which might be beneficial if we don't want to write out all that. And we can just do system.out.print. And we don't do the ln since we don't want lines in between, but we just do bone stacks of 0 plus space. And this is also logically equivalent to this, with the exception that it would add an extra space. Oh, not 0, I. This is logically, these 3 lines are logically equivalent to this, except it adds an extra space at the end, but it just saves us, like, spares us time from writing all that. But anyways, we submit our code. And we got it.
Okay, and thank you so much for going through the problems. So the first problem that in the problem set, the dog names, isn't actually something you guys learned last week. It's going to be something we're learning this week, which is strings. Miss Lorena just wanted some more practice before the 7 legs competition. But we'll go over like basically all the methods that were used for the first question, etc. A couple of other things related to what we learned last week that I didn't really go over. So you'll see that when we do for loops, we initiate like a variable, right? So usually it's I, and so we can do int I is equal to 0, I is less than 5, I plus plus. And so this loops through this code 5 times. So we can do system.out.println I. But if you have a variable before this for loop that already initializes I as something, and you try to run it, you'll get an error because you're trying to instantiate a variable or initialize a variable or define one twice. And so this code wouldn't work, which is why generally when you are making variables, you want to make it very specific and not something simple like just letters. But if you instead just get rid of this int, and so the declaration is just setting I equal to 0, you'll see that this will all of a sudden work again because you're not trying to declare I twice as something. A couple of other things. If you have 2 for loops, so if you have 2 for loops like this, even though we already declare I as 0 the first time, the scope of this variable only reaches through this for loop. And it's not something you really need to worry about now. Just know that if you have a for loop and you initialize this variable as equal to 0, you can do it for another for loop, and you can reuse the same variable name because this I basically goes away as soon as the for loop ends. And then the second thing is that if you have a nested for loop, so if you have 2 for loop, like a for loop inside of a for loop, like this, you can't have both of them be I because the same rule applies where you can't initialize I twice. So you would have to use something else. Usually you would use J. So those are just 2 small things that I didn't really cover last week, but it's pretty important when it comes to doing for loops. And of course, if you have any more questions, you can always reach out. Yeah.
Okay, can you go back to where you had the int I declared before the for loop? Okay, so here, yeah, you can do where instead of the int I equals 0 in the for loop, you have I equals 0, which Sam showed. We can also just get rid of that entire first statement. Just leave a semicolon before I is less than 5, and then that'll basically what it basically does is it skips that step. So say you already have your variable I that you want to iterate with outside and declared, then you can just leave a blank statement there, and then that'll it would just skip that step, and the loop still works.
Yeah. This initialization is basically just if you need to initialize a variable. You can also just like do something random here. I'm pretty sure. Like you just do like, oh wait, you do like long y is equal to 5. Like just something like completely random. Like it should also still work. Just because this is just a simple initialization. What really matters for the loop is the condition and then the iteration. Okay, those are just some like minor things I wanted to go over from last week that could be pretty useful if you want to continue using computer science like Java in the future. But this week we're going to go over strings, which is also very important. There are a lot of competition problems that require the use of strings, and especially in Novice, I think a good chunk of the problems require the use of the methods of strings. So what are strings? Strings basically are used to store text as a sequence of characters, and in Java, strings are treated like objects. And so what that means, all that means is that strings will have like methods that let you do certain commands to the string object, and we'll talk about that in a bit. But if you want to declare a string variable, you would have you would have a sequence of characters, and then you would put double quotes around it. So it's different from a character because a character would only have single quotes, and you can only have one character. While a string, you would have multiple. So of course, to create a variable of type string, you guys have probably done this in previous problems, but it's like it's basically the same as like creating any other variable. You have the type of the variable, which is string, and then you have the variable name, and then you have the assignment operator, which is the equal sign, and then you have what you want to set that variable equal to. So in this case, we want to set it equal to hello. And then of course, we also talked about concatenation, where you can concatenate two strings together. Where if you add a string and another string together, it just combines those two strings into one longer string. So string second greeting would have greeting plus another hello. So second greeting would just be hello, hello, with no space between the hellos. And then we talked about how strings are objects, and the most important method to know is the length method. And we kind of looked at like length last week when it comes to like arrays, etc. But like for arrays, it's not a method, so it doesn't have the parentheses afterwards. But because strings are objects, the length method is actually like you actually need the parentheses afterwards. And so for this line of code, you have string text is equal to hello world. So if you try to print out text.length, the .length method returns the length of the string, basically. So in this case, you would have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It includes spaces as well. So it would output 12. And so you'll learn that for methods, you'll either have return methods, which will return like a variable type, for example, or you'll have like other methods that won't return something, but will just change or will just perform an operation. But the length method will return an integer, which is the length of the string. And then there's some other useful methods related to the string object. The most important one is the car@, one, where you'll see that for the length, you don't put anything. There's no parameters that you put inside the parentheses, but the parentheses are there, so you can put parameters for the method to know exactly what you're trying to look for. So, for example, if you use the car@, method, it returns the character at a certain index that starts at 0. So like the arrays, the first character in a string would be at index 0. So if you did, for example, here, if you do text.character@ car@, and you put 0, and you put it in a system.out.println, it would print out a single H because it's the first index of the string. Substring is also pretty useful. Basically, if you have one long string and you only want to output a certain section of that string, you would use a substring method. And the substring method has two parameters. It has a start index and an end index. So it's the character that you start at and the one that you end at. And you'll see that in front of start, there's a hard bracket, and at the end of end, there's a soft bracket. That just means that you include the index of start, but you don't include the index of end. And so if you did text.substring 0 to 5, for example, you would include H, which is the 0th one, but 3, 4, 5. You would not include the space, which is the fifth one. So if you did text dot substring 0 to 5 and you try to print that out, you would output hello without the space because it doesn't include the end index. And then contains and equals are both pretty useful when it comes to like problem solving, because sometimes a problem would just ask you, does this string contain this sequence of characters? And so you would just do the string that they're trying to like make you, or the string that you're searching through, dot contains, and then you inside the contains, the parameter would be a string that you're trying to search for, and it'll return either true or false. So all of these methods are like return methods because they return some type of like variable type. And then the equals method is kind of similar to contains in that it returns true or false. It returns true if the first string that you have is equal to the string inside of the parameters. So if you have text dot equals like, and you put in parentheses, you put hello world, the same exact thing, it would return the true. If you don't have the exact same thing, it would return the false. Split is a bit more complicated, but for now, all you have to know is that if you put split and you put just two double quotes with a space in between, it'll turn a string into an array of all the substrings separated by the white space. So if you look at this example, hello world, if you did text dot split with the parenthesis or with the double quotes, it would turn into a string array of length 2 with hello as one of the elements and world exclamation mark as another one of the elements. And so the way you would use split is you would create a string array. You would do string bracket like s is equal to text dot split, because text dot split returns an array. So if you wanted to set it equal to, if you want to assign that array to a variable, you would need to create a string array variable. And then these are other pretty useful ones. 2-character array basically turns the string into the array of the characters inside of the string. So similar to split, if you wanted to assign this method, like what it returns, to a variable, you would need to create a character array first and then set it equal to whatever the string name is, dot 2-character array. And then index of basically returns the first, like the first occurrence of the string in the parameter, or it returns -1 if the string in the parameter str isn't in the string. And this string just refers to the string that you're using the operation on. So if we had a string of type, if we had a string and we called it text dot index of some string, this would refer to the text that we're talking about, the thing in front of it. And then 2 lowercase and 2 uppercase are both pretty easy. It just returns the same string, but all in lowercase or all uppercase. So this is pretty useful if like a question asks how many occurrences of the letter A are there, ignoring letter case, which means you don't care if it's uppercase or lowercase. So you can just turn the entire string into lowercase and then check to see if there are A's. Makes it a lot easier. And of course, here are some examples of the methods that we use. If we have a string called the alphabet, that's basically the entire alphabet, and we did alphabet.character at 5, we would see that 0, 1, 2, 3, 4, 5. We would output an F because that's the index of 5 of alphabet. And then alphabet.contains A, B, C, D, E, F. We see that because there is A, B, C, D, E, F, a substring of that inside of alphabet, it would output true. Alphabet.substring 1 to 5 would output B, C, D, and E, but not including F, because substring includes the first index but not the last index. And then 2 uppercase would basically just output A, B, C, D, E, F, G all the way to Z, but in uppercase, like all uppercase. And you'll see that the first one, character at, would give you F. It does contain A, B, C, D, E, F, so it would be true. Substring would output B through F, not including F. And then 2 uppercase would output A, B, C, D, E, F, G all the way to Z, all uppercase. Another thing to know about strings is escape characters. And these are useful because certain characters aren't going to be able to be used in strings, and it will just simply output an error. So for example, if you look at the string error, because double quotes are used in Java to differentiate what is inside the string and what's not, this will output an error because Java will see a starting quote here and an ending quote here, and a starting quote here and an ending quote here. But what's in between the output isn't something Java recognizes, so it outputs an error. But we have a / escape character to help circumvent these issues. So it's not something that is like it's not something that we can't do. We just need to use the escape character. And so the escape characters we have are \apostrophe, and this results in just a single apostrophe or a single quote. If we do \double quote, then it just simply results in one double quote. If we do 2 backslashes, it just results in 1 backslash. And these 3 are the primary ones that you need to worry about. There won't be many problems that require much more than this. And so if we want to fix our error, we would just put backslashes in front of the quotation marks. And then instead of causing an output, like an error, it would just recognize that this is an escape sequence. And then it would just output the quotation mark, the double quotes. And then some other escape sequences that are pretty useful are \n and \t. And so \n inserts a new line in the text at this point. And then \t inserts a tab at this point. So an example of \n would be if you didn't want to like put hello and world on 2 separate println lines, you could do hello \n world and would output it on 2 different lines. And then \t gives you a tab, and so if you try to do this, it would be hello tab world. So these are pretty useful. I think \n is probably really useful compared to \t. So are there any questions relating to what we talked about this week? Strings. All right. If not, I'll post the link to this week's problem set. There's 3 problems, and the problems are a bit more difficult. So I'll go over one of the problems in 4 or 5 minutes, around 2:26, and then that'll be it. And you guys have the rest of the time to work on the problem sets. And then if you have any questions, feel free to ask.